Hello, my name is Jan Dabros. I am working at SemiHalv. It's a software company based in Poland. And today I want to talk to you about unit testing coreboot. And this is basically a status update after 1 year. On the last OSFC, I was talking about the initial state of unit testing inside the coreboot. And today I would like to talk about the features which we implemented over the past year and whether our goals were reached and what are the plans for the future. Okay, so first of all, what is the test coverage right now? We have 46 tests, and last year it was only 7, so a big improvement here. We have 14 contributors right now. I'm talking only about the tests directory within a coreboot. And the vast majority of tests were written by Jakub Czapiga. It's my colleague from SemiHalv. And he is also a maintainer of a test directory. So basically every patch which is touching this testing area, he's reviewing these commits and provides some comments. Okay, main focus was on source lib modules, and we have 31 modules covered right now. And out of these modules, we have almost 88% functions covered. This is the state from November 2nd this year. Actually, this coverage, I will talk about this more later, but just to give you an idea that we are talking only about modules which are tested, which are which were taken to the compilation, right? Since modules which weren't compiled at all, they are not included in this statistics. And second note, actually, the status is lowered because we are not testing some weak functions, and coverity report is also including them in statistics. However, we are not covering them in the tests. Okay, so what are the improvements in the test framework over the past year? We have better mocks implementation. We are using our custom one instead of GCC wrap flag for the linker. And right now, with the new implementation, we can mock functions which are called within one module. So this is an improvement. We also can compile our unit test using Clang compiler right now, not only GCC. We have test coverage reports and per test config file generation. I will talk about these two last features in more details. Okay, so first of all, our coverage report. We can create a visualization of the status of our unit test, the percents of code lines and functions which are touched by our test, which are verified. Again, as I said, this is only about the modules which are tested, right? So if some module is not compiled at all, we are not taking this into consideration. There is a tutorial with instructions how to build and generate report on our coreboot repo. So everyone can use this and build the coverage report on your own, right? And so furthermore, we can use a test coverage report in order to verify which lines of our unit under test are verified, are touched by our test harness. And with this in place, we can easily improve the coverage rate. Okay, second feature, which I would like to talk about, is per test config file. Previously, when building a test, we were using QEMU default config. Right now, we have an option to configure our values and override the default ones from the default config. This is useful since coreboot is based on the configuration file, right? There is also a second benefit. We can use one test code, one source code, and using different config values, we can create different test cases. So basically, we can verify multiple configurations, combinations of config values in order to verify our code base. No need to write extra code. On this slide, you can see an excerpt from our test make file. And here we can see that only one test is defined in the details with sources, mocks, all configs, and so on. Then we can use a copy test macro in order to copy all variables and only overwrite the config value which we are interested in. Using this, when makefile is creating the configuration file config.h for particular test, it is parsing the variable and creating preprocessor entries based on the order from a makefile, right? So the latest value takes precedence over the earlier ones. Using this, we can easily test different configuration combinations and using only one test module, test code. Okay, so beside the improvements into unit testing framework, we have also a new feature introduced into lib payload. This is arcmock. Basically, we can right now build lib payload sources using a host compiler without using xcompile. This allows us to easily write unit test for lib payload content. And with this feature, we added a new framework for unit testing lib payload content, which is very similar to the coreboot one. And actually, the hierarchy and the directory structure of tests within lib payload mimics this which is used within coreboot. We have a sample test for driver speaker.c, which is already merged. And this framework for unit testing lib payload is included in 4.15 coreboot release. Beside testing lib payload content itself, we can also use ArcMock in order to unit test payloads, coreboot payloads, which are using lib payload. For example, depth charge is already using it. So we have two benefits from using this new ArcMock define. One is that we can test lib payload itself, and second, that we can easily unit test coreboot's payloads. Okay, and how this payload testing may look like. We have a simplified schema since this operation is pretty complicated. But what we need to do, we need to build lib payload using new mock architecture, this new mock arc feature. And we are linking this against other static libraries which are required. In case of depth charge, it's, for example, vboot. Then during the compilation and during the linking time, we need to prepare mocks from within a lib payload. So we need to make all symbols which we want to mock global, and also make them weak, so that we can easily override them in our test harness. And then linking this against payload unit under test and mocks and test framework, we can verify that interface between the payload and the lib payload is working correctly. So we can verify calls from the payload unit under test into lib payload, as well as calls from lib payload into our unit under test. Okay, so it was a quick brief through the items which we were able to accomplish over the last year. What are the plans for the future? First of all, better test coverage, both inside the coreboot and lib payload. This is actually a call for action for all of you, for all of us, to write more tests. Since more tests we have, the more reliable code is. Furthermore, we want to add ArcMock feature to the coreboot itself, so that we can unbind from x86 32 bits host architecture. Since right now, every test which is written within coreboot, when we build it, it's built as a 32 bits binary. In order to get rid of this limitation, we need to introduce ArcMock there. And last, we want to introduce some CMOCA improvements, our test framework. So first, we would like to allow to put multiple test groups results into one output XML, since right now we need to create a separate file for each test group. And second, we want to add support for default values returned by mocks. it may be useful, and currently CMOCA lacks such feature. Okay, thank you very much. And let's see if you have any questions. Thanks a lot.